Welcome back to our channel. Today, we're diving into the exciting world of physics engines in Java using JBullet. If you've never worked with a physics engine before, don't worry. We'll break everything down into manageable steps. By the end of this tutorial, you'll have a solid understanding of how to implement JBullet in your Java applications. First things first, let's understand what a physics engine is. A physics engine allows developers to simulate real-world physics in their applications, such as gravity, collisions, and other physical interactions. This can give your game or simulation a more realistic feel. Now, let's get familiar with JBullet, which is a Java port of the Bullet physics engine. JBullet is widely used in game development and simulations because it's efficient and provides a comprehensive API for 3D physics simulation. To get started, you need to have JBullet in your project. If you're using Maven, you can easily add it by including the following dependency in your pom.xml. If you're not using Maven, you can download JBullet directly from the GitHub repository and add it to your project's build path. Once that's done, let's start coding. Let's create a basic setup for a physics world. First, we need to initialize the physics world, which is the core component that manages all the physics calculations. Here's how you can set that up. With the physics world set up, let's add a simple floor to our simulation. We need to create a ground plane. This can be done with the following code. Next, let's add a dynamic object, like a bouncing ball, to our physics world. The following code demonstrates how to create a sphere and add it to the scene. To observe the physics simulation, we need to implement a simple loop where we update the physics world. Here's how you can do that. Now that we have our setup complete and everything is in place, let's compile and run the application. You should be able to see the ball falling onto the ground according to the physics calculations done by JBullet. Next, we can enhance our simulation further by adding collision detection. Collision detection allows us to respond to events when two objects interact, which is crucial for any physics-based application. For a more realistic simulation, you can adjust properties such as friction, restitution, and mass for your bodies. These properties drastically change how bodies interact during the physics simulation. Another interesting feature of physics engines is the ability to create joints between objects. This allows you to link two objects in a way that mimics real-world constraints. For example, let's create a hinge joint between our ball and a static object. As we build more complex systems, we can also manage multiple bodies and interactions. Understanding how to manipulate these bodies with different shapes and forces can create intricate simulations. If you want to take your physics simulations a step further, consider exploring advanced features such as soft body physics, complex collision detection scenarios, and continuous collision detection, which helps prevent fast-moving objects from passing through each other. Before we wrap up, let's do a quick recap of everything we've covered in this tutorial. 1. Setting up JBullet in a project. 2. Creating a physics world. 3. Adding static and dynamic objects. 4. Updating the physics world. 5. Implementing collision detection and response. 6. Adding physical properties to objects. 7. Creating joints for object interaction. By understanding these fundamentals, you can now start to create more complex interactions and simulations in your own projects. Whether you're developing a game, a simulation, or something entirely different, using a physics engine can significantly enhance your application's realism. As always, thank you for watching. If you enjoyed this tutorial, make sure to give us a thumbs up and subscribe for more content on Java programming and game development. If you have any questions or want to share your physics simulations, leave a comment below. Happy coding!